a great pleasure to introduce Sergey and Gleb, who will now tell you some more about why SCADA is important for us and why it's deeply broken. Thanks.
Hello, Congress. Nice to meet you again. Here we are, me, Sergey, and Gleb, but as usual, we only frontmen of SCADA StrangeLove team. Here's our team, and I ask you to applaud those guys who worked with us. Thank you, guys. Last year, we have a very good time here on Congress, and after this, we decided to spend more time hacking ICS system, hacking SCADA system to get some new materials to talk here again. So here we are, and we are talking about our first release. Our first release is new business metric to estimate cost of vulnerability. How to estimate it? You can now to find any vulnerability in ICS environment, you need not so much money. You can download ready-to-parsing stuff from scans.io, grab it by Elasticsearch, and if you want, put it in Excel. It's most expensive part for me. It's cost more than 9,000 because I hate it. But if you have, I don't know, PhD student, you can ask to do it by himself. Why are we talking about it? Because for last year, things changed. In 2012, we have Google Showdown, and this was very slow and boring. And now we have a ZMAP, MassScan, special homebrew scanner for industrial protocol, and it's very simple to get new information, up-to-date information about ICS system in internet. Here it is. So at the moment, in our knowledge base, we have more than 60,000 of different ICS devices. Of course, most of devices in US, but Germany on second place, and on third place is Italy, not with PISA owns only. And if we will check the statistic by vendors, we will find that on the first place, we can find not very common vendors, not, I don't know, Siemens or ABB. Why? Because a lot of ICS devices connected to internet, not directly, but via special network devices, which can be fingerprinted by common methods. If you check our statistics for top 10 devices, we will find WindCube on the first place. What is it? This is smart grid device. We use it to control solar and wind power generation stuff. So for me, smart grid, it's next big thing in ICS security, because many people buying some devices installed at home connected to internet to control power, to understand how many energy were generated, and this create additional vulnerabilities in such devices. Funny things related to protocol. You can see on this slide that only 2% of the all exposed devices was fingerprinted by using industrial protocol like S7, Modbus, or ARA. 98% it's HTTP, SMTP, and all other stuff, which not needed by ICS devices to work to, I don't know, to do things which was
so they're just for communicating with operators, for monitoring, for like management, configuration, and so on. But they're just there for us to make these statistics.
Yep. Thank you, Gleb. From industrial protocol point of view, most common protocol is S7 and Modbus, but this only because we have tools to fingerprint this protocol, and maybe this statistic will change next time because we will create additional toolkit. So our first special release for Congress, it's a list of dorks and fingerprints you can use to find ICS devices in your network or in internet. Please enjoy responsibly. Why it's important? You know, we finding devices in the internet not just for putting in Excel and to visit Congress. We're working with different certs, with international agency like Impact, with ENISA, to remove these devices from internet. So I think if you will launch ZMap next time to find one or two, I don't know, power grid device on internet, you will behave in similar way.
And maybe with our dorks, they will do it by themselves next time.
But you know, all this statistic, it's only part of the full picture, because very often during security assessment, you can find remote desktop or AirAdmin on the perimeter and of ICS network. And if you will guess password 12345, you will find that this device, which you can connect via remote management protocol, it's engineering station, which was exposed to internet by operator to simplify his day-by-day work. This very common situation. But things can be more interesting. For instance, during assessment of transportation system, we found that one genius, during deployment of in-train entertainment system, plug broadband internet from train to internet access from the train to the same switch which connected to computer-based interlocking system and process all ways transportation stuff, you know, signaling and so on. So if you connect something to internet, when internet can connect to you.
So what about industrial protocols? There are a lot of different information about this, and we have a lot of dedicated talks about industrial protocols by SCADA StrangeLove. In short, there are a lot of them. Some of them are easy, some of them are more complex, like not only manipulating some text on PLCs and changing the state, for example, of some turbine. They also can reconfigure devices, they also can refresh the devices and so on. And most of the stuff nowadays you can find on the internet, like things for fingerprinting, like things, even libraries to communicate with the different devices via these protocols. But not everything is research nowadays. For example, Honeywell's fault-tolerant Ethernet protocol. It's not even dissected by Wireshark, and it shares a lot of similarities with Profinet DCP protocol in terms of broadcasting requests in the subnet and gathering all the components to start the communication between them. And this is just work in progress, and we hope that soon Alexander Timorin will share with us Wireshark dissector. So here comes the first special release for this anniversary C3. It's brute forcer of Siemens PLC's S300, a model for Hydra.
We will run a demo. We can skip introduction. I think everybody here can use a map to find devices on on port 102. It's a S7 protocol. After you can use, for instance, PLC scan tool. It's open source tool. You can easily contribute it to check this port against S7 fingerprints. Yep. Here is the list of the devices, and one of device return its capability, and we can see that this is S7 300 PLC. So after, you can use new Hydra, thanks to one Hauser who built it to check this device against most common passwords. We also gather it during our penetration test. And here is the magic. It works. It should work, for sure. It's video. So here it is. And once again, thank you for One Hauser and the Hackers' Choice team.
So, again, about last year. Last year we talked a lot about different vulnerabilities, and we had no ability to disclose a lot of details. But this year we can try to put some things about these vulnerabilities. And talking about them, we will try to build some attack vector on Siemens WinCC installation. Let's just assume we somehow have an access to the subnets with Siemens WinCC, HMI, PLCs, and SCADA server. And here it goes. We are unauthorized, and well, first vulnerability. It's actually very bad because it's very easy to use. It gives you a lot of privileges, and there are too many devices facing the internet right now. Well, we will just not talk about it, but we will give a small challenge. First one who will guess the protocol, he will get a free t-shirt or free beer after this talk or during tomorrow's workshop. So we are waiting. Okay, here is the guy. Okay, I will. So we did not told you anything about this vulnerability, but now when we have remote unauthenticated access to the database, okay, what next should we do? To develop our attack vector, we should think about post-exploitation. It's just about what we can get on the compromised host. And there is a next vulnerability. Next vulnerability is about the encryption of passwords, SCADA users' passwords in the project database. this decryption model is in our Metasploit model that can harvest a lot of different valuable information from this database. And last year we actually wasn't that responsible because we didn't told a lot about this decryption, about this encryption, but actually everything was on the slide. It just, if you make an exclusive OR of ciphertext plus user plus this encryption key, then you will get the password in clear text. Well, yeah, that's it. Actually, most of the SCADA system, they follow the trend of using XOR and exclusive OR, and it comes in many phases, like they're trying to rotate something or to use some tables as a key, which is more more serious encryptions, but still bad. And actually, what else? What are the things that we saw in ICS systems this year is a real simple substitution encryption. So guys were storing passwords with a simple table of substitution of chars. But on the other hand, not everybody is that bad, and sometimes, like Siemens TIA portal, we see these things. This is the project file, and this is very good hashing of SCADA user password. It's not even MD5, and we were like, what the hell, what we are going to do? But next thing is that they wrote down the password length in this the same file, which simplifies the cracking process a lot. Actually, there are two hints. The next hint is some structure that represents the password itself, but somehow hidden by unique bytes.
Yeah, it seems like it was here, but now it's overwritten. Yep.
So now we are on the SCADA server, and we are not, for example, we are not a privileged user. We're like an operator that can control some things, like he can monitor processes, maybe he can react in some situations, but he has no complete access to the process. So what should we do? We should analyze the WinCC architecture itself. So if we look a little deeper, then much deeper, okay. We can see that there is a core service on the SCADA server that is working with several internal WinCC protocols, like CAL, PAL, CSS, and so on. And what this protocol core service does, he's working with components. So this service is managing the communications between different components, and components are like HMI, PLC, and so on. So, these components, they should call some function from this service to register itself. And this is the function they need to call, and the first argument is very interesting. It's called components GUID. So right now, to access any component from unprivileged user, we should somehow control this components GUID. And what if we can send it in our user packet? Yeah, we're sending it in our user packet, and now, I don't know how operator will do it, but somehow with some skills, can manage to craft a special packet with special payload to control PLCs from very low-profile accounts on the SCADA server.
Next vulnerability was presented by Timur Yunusov and Alexey Osipov at Black Hat. It's XCC out of band, a very straightforward vulnerability. So you can send to server XML file, which will trigger server to request additional XML file, which will process it by server, and after this, server will send some information from file system by HTTP or SMB or our protocol. You can manipulate with it. This is very interesting vulnerability because a lot of guys have a vulnerability. Even TrustWave with mod security have this issue, in rule to protect you against zero-day exploit. But when we start to check this vulnerability against ICS environment, we start to thinking how we can apply this vulnerability to ICS. And one of the target was project. You know, what is a project in ICS? It's a type of development project. So you have a program, you have additional configuration, and typically configuration stored in XML files. So we decide to research, can project be trusted, and can project be used to spread malware like Adobe file used at the moment. Unfortunately, project cannot be trusted because most of the ICS system don't have built-in integrity control features. So if somebody can modify project, this project will be used on different SCADA system and can be used to execute, for instance, any code and to patch system. So how it can be abused? It's a very trivial task. You can simply patch event handlers. For instance, if you have event handlers on mouse click on your ICS project when somebody clicking on the button, I don't know, to launch a rocket, you can patch it and add something like create text file and write your malware here. Of course, you should convert it to ASCII, but this is not a challenge. But sometimes we have a question. Of course, but NERC SIP require to have antivirus on the SCADA network. So you should make your malware invisible for antivirus. It was a joke. Okay. Here is typical setup of antivirus in SCADA network. As you can see, there is exceptions. And exceptions include all SCADA stuff. SCADA installation path, SCADA project path, and so on. And this SCADA system NERC SIP compliant. Why? Because this is vendor requirement. So if you work against, if you want to hack, I don't know, ICS system, sometimes it's very useful to read documentation.
So now we will talk about vulnerabilities again. Now you can see on the slide, this is the statistics of vulnerabilities by SCADA StrangeLove, by all these people you saw on the second slide. And now we have like more than 150 different vulnerabilities. And if we see them by type, you can see that most of them are easy to use and easy to find cross-site scripting attacks. But next is remote code execution. And that's not your Windows server like from this year. This is old hardware and old software, and this software does not have ISLR most of the time. Most of the time it does not have data execution prevention, so exploitation is very, very easy. And you don't see from this diagram the whole picture like these cool choices that were made by different vendors, like how cool it would be to write your own HTTP server. And this is the statistics of Apache HTTP server. And maybe to write your own DNS server. Also, this is the statistics for ICS bind. Well, these vulnerabilities, well, I don't know, this software can be fixed because they will have, again, vulnerabilities for 20 years. The only fix is actually to use some existing software, and I think actually it would be easier. So why the fixing is so hard process? Also, because as you see, this is WinCC HMI software, and this is the dates when different libraries and code was compiled. Actually, most of the code was compiled before the Stuxnet, so we can see like how small part of things have changed. So how these bugs are found? Here's nothing new. You just take some solution, you just strip it on components like HMI, PLC, SCADA server, DSC server, and so on. You understand how they communicate, how they process data, how they store data. Then you find a number of entry points and try to analyze it with black box or gray box, reverse engineering, so on and so on. Well, let's assume, for example, you see when you found like entry points, you see something like this, and most of the time when we found different vulnerabilities, we see these things. All these things are bad. They are not actually ready vulnerabilities you can exploit, but this is like small signs that you can somehow control the memory, the code, and so on and so on. And this is not the picture from the real world, because the data like receiving and data processing, they're usually in different libraries, in different objects, and so on, structures. So looking at this picture, we thought that we build a small challenge. Who will find more vulnerabilities with simple regexes? And what we did, we decompiled one of a binary and grabbed it for REST call. And we saw something like this. And then we grabbed the same function for the uses of these variables. Of course, you can see that we can see the whole picture, like we're not building the CFG of DFG. So the assignments, we can see like other variables. We can see the calls nearby, but we can see this. Well, as I said, that wasn't going to work in the real world until we actually took one solution, decompiled the whole code, libraries, and so on. And then, well, we wrote a script like 50 lines, like not only to grab, just to analyze all the data. And this is one of the examples. So there are a lot of output like this that was, and surely these things should be reviewed by hand and so on. But the results, verified results, were amazing. We found 7 remote code executions and 4 DOSes with this cheap script, not like all those pricey static analyzers. Imagine what Lint can do with this. So who is this? We don't know yet. Maybe next year. Well, let's think about why these things can actually happen, because that's very bad. And maybe the programmers, they don't know about security a lot, but this is the piece of code in between those RCs. They're checking the buffer for some limit, and they're printing the string that, okay, here is the buffer overflow. But next thing they do is they allocate the memory and copy the buffer.
You know, sometimes internet is a very dangerous space. And one day during Twitter conversation, we understood that all things we're doing does not exist. Because there are no penetration testing in ICS environment, and so it was very bad. So we decided to share with you main secret of ICS security. When you go into make ICS pen test, please remember, for IT pen test, your goal is to break stuff. For ICS pen test, your goal not to break stuff. Or you will be fired. So leave at your home your favorite zero-day toolkit, your Kali Linux, and take your camera. Because in most cases, assessment, we call it paparazzi style assessment, sometimes you even don't touch keyboard. You ask an operator to provide information for you. So you say, okay, guys, let's open registry editor, let's find this line, and so on, especially for production environment. So how to work in this situation? Most important thing is to have a lab. If you don't have a lab, you will play with real system in real environment, and this will be a bit dangerous. So we bring part of the lab here, and tomorrow we will have a small workshop. If you will join, we will be happy. And please, sorry for this promotion, but if you will join us, please bring some network devices like wireless access point and switches, because we don't have it here in Germany too much.
And yeah, one important thing about this is sometimes when you are doing assessments, how Sergey called it, paparazzi style, you are showing actual operators, for example, how to escape kiosk mode on their HMIs. So they can access file system, they can access CMD, and so on. And actually, almost all customers have their own laboratories. So when you analyze, you are doing, for the first part, you are doing an IT pen test, and then you are doing ICS pen test in the lab. And then with this paparazzi style, you can connect all these results. And it's not always laboratory, because things are changing all the time. And for example, some part of the SCADA is just in the process of integrating with the whole, for example, plant. Some parts of the system, like the turbine, is broken and it's on repair. And sometimes it's, summer and some thermal power plant, you don't need so much energy, and some parts are turned off. So it's all about proper methodology and time.
Yep. And project management sometimes, yes. Important part of ICS security, it's fixing stuff. Not to breaking stuff, but fixing stuff. And we want to share our experience. Here's a typical fixing timeline. In 2011, somebody put in blog information about 0 days in SCADA system, and in 2013, it's still actual information. So vulnerabilities was not fixed, and now available for sale, I think. One more example of our experience. We trying to reach one big Japan vendor of SCADA system to fix vulnerability. We spend a lot of time without any response. We call into the phone, send an email, no answer. But thanks for S4 conference, we met guys from Japan CERT and asked them to help us. We say, okay, connection is established, please send information about vulnerability. We share it and starting to wait. And one day, guys from Japan say, guys, everything is fine. Customer list completed. What is customer list? Why it's so important? It's important because guys from this vendor decide not to publish information about fix, but silently patch it without any notification. You know, last time I saw it in IT world in the beginning of the century. But in ICS world, it's still common. We will silently patch this vulnerability without any notification. At the moment, we still don't know, is it patched or not? And postscriptum. Last year, we have a question about SCADA in the cloud. So even more Modbus go to the cloud, and as it's in cloud, you can easily find it in the internet if you need it. Sometimes things more difficult. For instance, SCADA in the cloud can mean RDP connection to virtual machine when you can monitor your system. We try to check it, how it works, and find it's gas view, yes, I guess, or maybe oil. I think everybody should have his own gas view. But the problem with, as Gleb said, with kiosk mode, that you can escape from kiosk and connect to gas view of our guy, to, I don't know, to manage it. So SCADA in the cloud is maybe good thing, but still it's have a lot of vulnerabilities. And of course, funny stuff with fixing. When we say, guys, you have a problem with your cloud installation, somebody can escape kiosk mode and do bad things. We say, okay, yes, he can, but just don't do it in your environment. We will not, but somebody, who knows?
Also, he's writing that this is a virtual machine, but there are internal network interface with local IP addresses and so on, so we can develop an attack also.
Not really.
No.
So thank you, and questions, please. Thank you.
So yes, for the questions, I would like to ask you to keep your questions short, to actually ask questions. If you'd like to comment on something, send them an email. If you'd like to give them advice, send them an email too. And questions can come now. Signal Angel, do we have questions from the internet?
Yes, we have one question. Have you seen anything like a proxy or translator between IEC 101 and 104 open on the internet? Because that would be expose the legacy systems.
Please repeat the question and hold your mic steady at your mouth.
Have you seen anything like a proxy or translator between IEC 101 and 104 open to the internet?
Like, I see, yeah. Like this, like here is IAC 104. We actually don't have any complete information about what's behind this, so we're just fingerprinting these things. We can't differentiate things, like it's proxy, it's gateway, it's actually RTU, or so on.
Thank you. Microphone 1, please ask your question.
How much of the stuff is, which is visible on the internet is some testing, research, or honeypot stuff, and how much of it is actual ICS systems? Because with some of the Google Docs, there was stuff that just didn't look right. So can you estimate how much of them are just honeypots or research networks, and how many of them are real stuff?
We will be really thankful for the feedback about the dorks, but we like an open project. We can differentiate, as I said, about the things that's behind those IP addresses and behind the banner. So if you somehow manage to understand this and tell us that this is a false positive, we will delete this dork or delete this IP address and so on.
No, the dogs are okay. It's just, it looks weird. The stuff looks weird sometimes.
Yeah, for sure, but you know, I'm not sure that at the moment there are a lot of ICS honeypot, maybe 1,000, but for these numbers it's very little percent of false positives.
Okay, thanks.
Thank you.
Thank you.
Microphone number 2, please ask your question.
Hello, I would like to know the systems you see on the internet. Is it just like monitoring stuff, or can you do, for instance, control atomic reactors? Can you shed some light on that? How deep the control goes that you can achieve over these things?
Do you think we should put an honest answer to that live on stage here, or would you like to ask that question again in private later on?
Yeah, actually, that would be better, yeah.
Thank you then.
Are there any more questions? Signal Angel, do we have any more questions from the internet? They don't want to know anything. So, thank you for being here. Thank you, Sergey. Thank you, Gleb, for that astonishingly great talk.